Welcome to the channel. This is TechnoScope.
Welcome everybody to a new series that I've been planning for a while, but I'm just now starting. This is effectively the no scope. I've been giving you the tech side of everything. Now I'm going to give you the knowledge side of this channel. And starting off with electronics theory is what I'm going to do first. Some of you know that I have a degree in electronics. A lot of you probably don't. There are multiple reasons why I'm starting this, but one of the main reasons is because there is a lot of misinformation out there in the tech community, and I want to educate my viewers so that you know what to believe and what not to believe, so that you're not constantly falling for some of the marketing things that are going on out there. So basically what I'm going to do is give you basic knowledge of electronics, and I have about 13 videos already planned for this series. There will probably be more, but basically what I'm going to give you, I'm not going to teach you all the ins and outs of electronics. If you need an electronics degree, you will need to go to school, but when I get through with this stuff, you'll be able to work on electronics, or at least you should be able to. This won't be as much the hands-on stuff as it will be the theory end of it, but I will incorporate hands-on stuff. I will be getting some of the components and stuff that I have and demonstrating some of the things where I can. I don't have all the equipment that is necessary. Like, I don't have an oscilloscope, although I do want one. I need a new voltmeter. My old one just crapped out on me. But I will demo as much as I can, but for the main part, just think of this as more of the theory side of things. I'm going to teach you the basics, the ins and outs, and when you get through with this, you should be able to say, hey, I understand how that works, regardless of if you can actually, break it down to all the individual components. You'll be able to understand how it actually works. I guess let's go ahead and get started. This is episode 1 of the series. Like I said, so far there are 13 videos planned. It may be more. I don't want to give you everything at once. I don't want to make it too broad, but I will give you the basics today, and I will throw in a little bit of math. If you don't know, electronics is a lot of math, but it's it's based on a lot of math that you learned in high school. Now the advanced stuff can get into calculus and things like that. We will not be getting into calculus. But basically what we're going to start with right now is the bare minimum essentials. Ohm's Law. In this video, Ohm's Law, we're going to talk about DC current, the 3 parts, or actually 4 parts of DC current that you should know about. The graphical assist that help you calculate those type of things. And we're going to do a simple circuit at the end, and I'm going to tell you something that you should know about simple circuits. So by the end of this, you will be able to wire up, or at least understand how a simple circuit is wired and what the different components do. So we're going to start with Ohm's Law. And basically, Ohm's Law is the relation between voltage, resistance, and current in a circuit. Voltage, resistance, current, all of those 3 things are always related to one another. You always have voltage, you always have resistance, and you almost always have current. The current is going to depend on a couple of things, but almost always you'll have current. Ohm's Law. Voltage, current, resistance are the three main parts. Voltage is defined by electrical pressure. How hard you're trying to push the electrons through something. Current is defined by the amount of electrons that are flowing through something. And resistance is the opposition to that flow. And I've drawn this diagram right here basically to help us out. This green line right here represents a wire of some kind or conductor of some kind, with this part right here that's squeezed together representing the resistance. And this blue blob is trying to get through this narrowing right here is your electron. And the purple right here is the pressure on that electron to push it through. Now, I did borrow this from a graphic that I found on the internet, but for copyright reasons and so on and so forth, I did not use it. I just kind of adapted it to my own need. But basically, you have your electron trying to flow through the conductor, and you have right here, which is the purple, your voltage. This basically applying pressure to that electron. It's applying pressure to that electron, trying to force it through. And basically, you have this resistor right here that's wrapped around it, squeezing it tight, slowing it down so that it can't flow as easily as it wants to. And this is basically how Ohm's Law works. This is a main principle in physics. Period. If you look at a freeway, you got cars going through the freeway. The speed of the cars is the pressure or voltage, whatever. The amount of cars is the current, and then you have the roadway. And we all know that if a lane all of a sudden ends on a freeway, all of a sudden you get a backup behind because there's a lot more trying to go through than what it's allowed to go through. And it's the same principle as that. Okay, so in DC circuits, basically it's saying that you have a power source, some kind of load, could be a light bulb, could be a motor, could be whatever. That's your load, that's your power source. Positive, negative. So this is a battery of some kind. And in a DC circuit, voltage always, or current always flows in one direction. We say the electrons flow from the negative to the positive. And the reason we say that is because on a subatomic scale, as we think of electrons and protons, that would be your proton and that would be your electron. My professor related it to going to a store. If this was you right here and you're going to the store, you always go to the store. The store never comes to you. The store is a lot bigger than you are, and it's just all kinds of easier for you to go to the store rather than the store to go to you. So that's basically why we say that electricity flows from negative to positive. It's just easier that way. Of course, we can't see electrons and protons, but I'm sure there is all kinds of math and other things that has proven it. That's how it works. But for all you really need to know is that it flows from negative to positive. In a DC circuit, always one direction. You can have multiple paths. You can have multiple power sources. But your power always flows from negative to positive. Now, I guess I'll go ahead and throw this in there because you'll need to know it for a future video. The reason that we have a flow of current is because this side over here, which is positive, is said to have a lack of electrons. And electrons have a negative charge, want to be with the positive charge. So if we have a lack of electrons on the positive side, we have a surplus on the negative side in relationship to the balance of this circuit. So the electrons are going to leave the negative side because like forces oppose, and they're going to flow through the circuit towards the positive side because opposites attract. So you have your electron flow always one direction, always from negative to positive. DC stands for direct current. Always one direction. It goes one place to the other. It's directly going there. So that's what a DC circuit is. Let's see. This right here, in schematic terms, is what we call a resistive load or whatever. As far as schematics go, that's what I'm going to use for resistors. That's just like the general, what do you call it? That's what's common to the industry. That's a resistor. This is your power source. We're talking about three properties of current flow in a DC circuit. So voltage, like your outlet is 120 volts. That's voltage. Where 120 is quantifying the voltage, how many volts there are. And when we calculate it, use it in a formula, we use the letter E for voltage. When we give a voltage, we use the letter V to stand for volts. So voltage, E in the formula, V to represent that it's volts, so 120 volts. That's the pressure, the electrical pressure pushing on those electrons. That's how hard they want to get from one place to the other. Current. This is the big one right here. This is the one that will get you in trouble because a lot of people don't really understand current. This is the one that determines what size wire you need to use, what size resistor you need to use, how much heat you need to dissipate, all of that kind of stuff. When you're talking about graphics cards or whatever it may be, current is the one that will get you into trouble. Current, basically, in our formulas, current is represented by the letter I whenever we calculate it. Whenever we write it out, we use the letter A. So 2 amps, oh I'm sorry, I guess I should have said that. We use the letter I, current is rated in amps. This is volts, this is amps. So when we write it out, we use a letter A. Current, letter I, amps, 2 amps is how that's read. And the last property that you need to know, resistance. This one, as you will see later, can change depending on what it's the resistance of, but typically resistance is represented by the letter R in the formula. It's measured in ohms, directly from Ohm's Law itself. And when we write it down, we will write it such as the Greek letter omega. So this is read as 120 volts, 2 amps, 4 ohms. And if you know anything about electronics, those numbers do not add up. They're just examples. So yeah, the Greek letter omega, which looks like an upside down horseshoe. It's rated in ohms, as in Ohm's Law, and in a formula we use the letter R. And there is one more, but I will get to that in a little while. This is what you're going to be using. These are going to be the properties of a circuit. Any other things that you get or are given are going to be calculated, basically. And I'll get to that. Okay, so now we're going to start on the next part that you need to know. And I guess I will zoom this in a little bit so that you can... That's as zoomed in as it's going to get. Okay, so you have EIR, your voltage, your current, and your resistance. We already know that. We just talked about that. So, an easy way to understand the relationship between those three is to use a pie chart. Okay, so basically how this works is anytime you have one of these pie charts and something is over something else, you will calculate the unknown variable by taking this one and dividing it by the one that you have. So if I don't know the current, I have the voltage and the resistance, but I don't know the current, I will take E and I will divide it by R to give you I. Likewise, if I have the voltage and I know how much current is flowing through the circuit, but I don't know what the resistance is, I can take E divided by I and it'll give me R. Also, on one of these pie charts, anything that's side by side is obviously going to be the opposite of divide, which is multiply. So if I have I and R, but I don't know what E is, I can multiply I times R and it'll give me E. And that's usually rare in electronics unless you're dealing with like a super high voltage or something. Usually you'll know what the voltage is, but say that you know how much current's going through it, you know what the resistance is, but you don't know what the voltage is, you multiply those two, it will give you the voltage. Okay, so that's all you need to know on that one. We will do examples later. So now we talk about the fourth property, which is a calculator property. In physics, you typically use joules to represent energy, but in electronics, the overall energy is calculated in wattage or watts. So for power, we use watts, also called wattage. And I guess I should have mentioned in the other ones. Volts is also called voltage. Amps is also called amperes. And resistance is just resistance. Power is calculated by taking a pie chart and literally spelling out pi. It didn't get any much easier than that. Okay, so your power is the voltage represented by E times I, the current. So you take your voltage, you multiply by the current, it will give you the wattage. You got, likewise, if you have a power rating, this is very common, especially in cars. You'll have a power rating and you'll have your voltage, because a car is usually 12 volts, or on average 12 volts. If you know what the power is, you know what the voltage is, you take the power, you divide it by voltage, you get the current. And the current will tell you how big of a wire you need, or how much, how heavy duty something has to be. So, but likewise, if you have the power, you have the current, but you don't know what the voltage is for some reason, take power divided by current, it'll give you what the voltage is. And multiply, divide. It works exactly the same as the last pie chart. This one right here, the other one is EIR. This one is pi, P-I-E. Very simple. And like I said, it's measured in watts. So the last thing I'm going to do is show you a simple circuit. This circuit is going to be unrealistic, but I'm just going to try to give you something very simple, because I don't want to pull out the calculator on you right now. I'm trying to walk you through the basics of how this stuff works. So we're going to take a simple circuit right here, right? This is going to be 12 volts. This over here is going to be, let's say 4 ohms. Okay? We know the current flows in that direction because this is the negative. And by the way, in most schematics, the bottom is usually negative. And sometimes you'll see this little thing down here. Looks like that. That's a ground. And ground is almost always negative. It's just the universal way of doing things. You can use positive for ground, but I really wouldn't recommend it ever, because unless the person working on it knows specifically that for some reason you're using positive for ground, you can cause bad things to happen. So almost always negative will be at the bottom. It will almost always be connected to ground. If you're connected to ground, sometimes they have a floating ground thing. That's far more advanced. But anyway, 12 volts, 4 ohms, current flows in this direction, counterclockwise. So what we want to find out is how much current is flowing through this. So basically what we do is we take 12 volts. Remember our chart, EIR, voltage over current times resistance. Basically, what we're going to do is we're going to take 12 volts and we're going to divide it by 4 ohms. When you take 12, you divide it by 4, it gives you 3. Very simple. So what you have left right here, you have 3 amps of current. That's a heavy duty circuit. And I guess in cars, 3 amps is pretty common. In houses, high voltage things, 3 amps is ridiculous. But in a car, that's kind of common. So we have this 4 ohm load, and we have 3 amps of current. Now, why did I use 4 ohms? Well, let's do this. Let's calculate what the power is. Remember what power is, right? Pi. Some people say easy as pie. I've heard that in a lot of my classes. I tend not to memorize those sayings and expression, but power is easy as pie. We have 3 amps. We have 12 volts. 12 times 3 is what, 36? So this right here, 4 ohm load, is dissipating 36 watts of power. What does it do with it? Well, it depends. If it's a resistor, it's dissipating 36 watts of heat. If it's a speaker, for instance, it's moving a cone and using 36 watts of power to move that cone. Now, that's why I use 4 ohms, because 4 ohms is a common resistance used in speakers. It's actually called impedance. There's reasons for that, but stick with me here. We're calling it resistance, and it's 4 ohms. 12 volts at 4 ohms gives you 36 watts. Now, I don't know about you, but I've been to the store and I've seen speakers that claim that they can handle 500 and 1,000 watts, crazy numbers like that. And if you go to the really cheap stores, they might even say they can handle like 3,000 watts. That's a whole other thing. It's basically calculation manipulation. But what if we wanted this 4 ohm speaker to handle more than 36 watts? Well, they have 2 ohm speakers. But if this drops down to 2 ohms, guess what this does? This is half the resistance. This is going to be double the current because of this relationship right here. It's not just I times R, it's also a ratio. So this should be double. So let's go ahead and just figure that out. 12 volts divided by 2 ohms gives you what? 6 amps, right? So by decreasing the resistance by half, I doubled the current that was flowing through the circuit. Now I need wire that's twice the size of what I had before. 12 times 6 is going to be twice that, which is going to now be 72 watts. So now I have a 72 watt speaker. That's still nowhere close to 500 watts. Nowhere close to it. So, have a problem on our hands, don't we? Okay, I'm not gonna do that because it would just confuse you. But basically what I'm getting at is that 2 ohms is nearly a short. If I went down 1 more ohm, if this is still 12 volts over here, this is 6 amps at 2 ohms, and I reduce this 2 ohm to 1 ohm, this doubles again to 12 amps, and then I have 12 times 12, which is 144. Still not 155. I'm sorry, 144. Still not 500 watts. I would have to go into fractions of an ohm. Now, I'm not really getting into this tonight, but there are problems with transistors. If you know anything about, let's relate it to other things that we talk about on this channel. If you know anything about graphics cards or CPUs, when you overclock, when you push a transistor too hard, things get unstable. It's the same way. One transistor or a million transistors in a CPU, it doesn't matter. If you push the transistor too hard, things get unstable, which is why it's better to keep a high resistance load, such as like a 8 ohm speaker like they use in houses, rather than it is to go towards 4, 2, or 1 ohms like they use in cars. The reason they use those low impedance in cars is because the voltage is so low. You're starting out with 12 volts, and what you have to do if you want to get 500 watts over here at a speaker. Sorry about that. You got the speaker, you want 500 watts delivered to the speaker. That 12 volts has to be ramped up significantly to a higher voltage to be able to make that 1, 2, or 4 ohm speaker give you 500 watts of production. And that's basically what a car amp does. Most of the electronics in a car amplifier is the power supply, where they're taking that 12 volts and ramping the voltage up so that they can give you a higher voltage. and then you have like the small part over there in the amplifier that actually does the output. That part's real simple. It's getting the voltage up there with a high enough current and supply to actually give you that music. That's the hard part. So basically, that's pretty much what I wanted to cover on that. I just want to cover one more thing before I go. Draw my circuit again, even though I just erased it. Okay, so remember what I said about this also being a ratio? Remember what I said about them being calculations? Do you remember in high school when your teacher told you never divide by 0? This is the reason why. This is where that finally comes in use, when you finally understand why. Because this is how it works. If you have a voltage, a power source that's supplying power, say like a car battery, you have a calculated value, right? This is 2 ohms. We just calculated this. If this is 2 ohms, this is 6 amps, right? So what if you take a wire and you connect one side of the battery to the other and bypass everything? This is what we call a short in electronics. Shorts are bad. The resistance of a short, God, that's horrible. Sorry about that. The resistance of a short is 0 ohms. 12 volts. Remember our chart up there, 12 volts, 0 ohms. 0 goes into 12 an infinite amount of times. So your current is infinity. This is why you do not divide by 0. 0 is a short. There's no resistance here. So this, the power supply, the power source, power supply, whatever it may be, is going to try to go to infinite power until you get to a point where the power supply can't produce any more power, or the things that are connected in it burn up. So that's where fuses come into place. That's where circuit breakers come into place. This is where you start getting sparks, arcs, things catching on fire. You do not want a short in electronics, period. 0 ohms is bad. Dividing by 0 is bad. Infinite current is bad. You do not want that. So never short a circuit. You always need some kind of load. You ever installed a high power capacitor in a car? That's why they give you that little light bulb, because when you first hook it up, it's kind of like hooking up a dead short to your battery. You don't want a dead short ever. And we'll get into capacitors later. Those things are really fascinating to me. Anyway, if there are any questions or anything, if there's anything that you need to know, something that I didn't cover in this basic part right here, let me know. Ask all your questions. Let me try to clear all those up. Remember your charts. Anything that's over something, you divide. Anything that's beside something, you multiply. These two are ratios. This is just the basics to get your foot in the door so you understand what's going on in electronics. It's not really hard to comprehend. It just gets a little complicated the more you add to it. But if you can understand how computers work and how to put a computer together and how to work on a computer, you can understand this stuff. It's very simple. So that concludes the first no scope. And if you have any, like I said, if you have any questions, feel free to ask those in the comments below, and I'll try to answer them. Also, if you have an electronics degree and you would like to have some input on this video series, let me know. Feel free to correct anything that you think I might have misspoken on. That happens. This is not scripted. I'm trying to do it off the top of my head. I do have a little outline thing, but it's not scripted. So if I misspoken or said something wrong, feel free to correct me. Feel free to help those in the community if you know this stuff. And I think we'll take it from here. We got some more videos to go. Got a lot more videos to go, and the no scope hopefully will be a good series on this channel. Guess that's it for tonight. Go ahead and like this video if you liked it, if it helped it at all in any kind of way. If you dislike it, I'll understand. Some people dislike all my videos for no reason whatsoever. Even if I make a short 2-minute video and I get straight to the point and tell you exactly what I said that the video was about, some people still dislike it. I don't know. But do what you gotta do. Like it, dislike it. Subscribe to the channel. Please subscribe. Please share. Share this video everywhere. That helps more than anything else. Even more than subscribing. Sharing my videos helps more than anything else. If there's anything I can do for you, let me know. My name is Elemento, and this is TechnoScope.
TechnoScope is a Twisted Curve production.